This is problem 14 of chapter 17 from the textbook Stats Modeling the World, second edition. And it's typically a class example problem, and I've made this video so that you can go back through this if you missed the class, or if you just want to double check your answers, make sure that you understand what's going on. So let's just get going. We have an Olympic archer that's shooting and trying to hit a bullseye. So we have what we call a success failure condition. Okay, we're either going to hit the bullseye or we're going to miss. Okay, and then the probability is fixed. It's 80%. So we have the probability will not change from shot to shot. And we're also going to say that each shot is independent. Okay, so now we're going to these are sort of what we call Bernoulli conditions, and then within the Bernoulli conditions there's two types. There's a geometric type of problem, and there's a binomial. So first we're going to do the geometric type, and I think you're going to find they're not too hard to do. So here we want to know, if she shoots 6 arrows, what's the probability her first bullseye comes on the 3rd arrow? So you can kind of model that with a tree. So we're either going to get a hit, right, a hit, or a miss. So that's going to be 0.8, 0.8, and 0.2. And then again, a hit or a miss, hit, miss, hit, miss, and then again, and again, like this. But we want the first bullseye comes on the 3rd arrow. So the probability of the first hit on the 3rd shot, so to speak, is simply going to be, well, we're going to have a miss. We're going this way. We miss, and then we get a hit. So that would be 0.2 squared times 0.8. And that comes out to be 0.032. Okay? So she misses the bullseye at least once. So there's no way I can draw a tree. Let's draw a little bit better tree, but let's go out 3 times again. But I'll try to clean it up because that was kind of messy. So we have a hit or a miss, a hit, a miss, a hit, a miss, a hit, no, a miss, a hit, a miss, hit, miss, hit, miss. So now let's see. We want the probability miss the bullseye at least once. So we're going to go out 6 times, but if you can kind of see, the only one it doesn't include is if you hit it all the time. So it includes all of these. So what we can do, this is sort of like, we can find this probability and subtract it from 1. We can use the complement. The probability of, this would be 3 hits. We're interested in probability of 6. So let's say that this is going to be equal to 1 minus, so if we think about this, this is 0.8, 0.8, 0.8, and then we're going to go out 6 times, so it's 0.8. That was kind of too sloppy. It was 0.8, 6 of those. Okay, and let's see, that's going to equal 0.0 0.738. Okay, so now the next one, her first bullseye comes on the fourth or fifth arrow. So that would be the probability that x equals 4 or x equals 5. So that's the probability of x equal 4 plus the probability of x equals 5. So now you have to keep in mind that this is a geometric problem. Okay, so when we say 4 here for a geometric problem, we really mean that the first hit came on the fourth arrow. So let me see, maybe I can do this. I can reuse this stuff here. I got rid of that. So what happens is we miss, we miss, we miss, and then finally we get a hit on the fourth shot. So this probability would be 0.2, because that's the probability you miss. So 0.2 times 0.2 times 0.2 times 0.8. So it's 0.2 times 0.8, and that would be to the third. And then here, probability of x equals 5, so we're going to go out one more. We're going to miss 4 times and then get a hit on the fifth shot. So that's just going to be 0.2 to the fourth times 0.8. And that comes to, let's see, I get 0.00768. Now there is another way to do this if you want to use a calculator. If you want to use a calculator, you can say genome P, I think it's genome PDF, and you put in the probability of success and then the number you're interested in, the first success. This is the first success. So you do it twice. Let me just double check the spelling. GEOM, I guess. GEOM. PDF. Make sure you use PDF, not CDF. And put in a 5. And you'll get the same thing. Okay? You'll get this term, and you should get that term. So you get the same answer. But you can use your calculator if you want. Especially if you don't, if you don't see the tree very well. Okay, now these next examples are going to be binomial. And the reason is let's read it. You'll kind of see. She gets exactly 4 bullseyes. And we probably need to say out of 6 shots. So geometric is when we're looking at when we get our first success. Binomial situation is when we're looking for k successes out of n trials. Okay, so a lot of times what I like to do is just build a model. So I'm going to do it right here, a probability model. If n is huge, it's a little bit harder to do, but it's not that hard to do in this situation because our outcomes are 0. So you could miss all. You shoot 6 times, you miss them all, or you get 1 of them right, or 2, 3, 4, 5, and 6. Okay, and then we do P of X. Now it would take a lot of work to fill this table in. So I'm just using this as a guide to see if I understand the question. So here, I believe they're asking, what's the probability that X equals exactly 4? So what they mean is just that probability right here. What is this? Well, fortunately, we have the calculator command to our rescue. So we can say binom PDF. Only use PDF when you only want one value. And what we do is we put in the number of, I think we put in the probability. I always have to check the probability of, where is it? No, we put in a number of trials. So the number of trials first, n, and then we put in the probability of success is 0.8, and then we put the number of successes we're interested in this case 4. We want exactly 4 successes. Okay, and if you do that, so you use second distribute, and you'll find it in there, and that answer is going to be 0.246. Okay, so that's how I would do that particular problem. Now, let me clean this up just a little bit. I want to get rid of this. I want to reuse my picture if I can. And what I'm going to do is I'm going to do this one first. We really should be doing F first. So here they want to know what's the probability of you get at most 4. So at most 4. So that would be the sum of all of these probabilities. Okay? All of those. So we want the probability of x less than or equal to 4. Okay, so there we just use this calculator function, binom CDF. Think of it as a cumulative CDF, and we put in 6n, again, the probability of success, which is fixed, and then we put in 4. Okay, but this time, because we're saying CDF, the calculator is going to take 4 and everything less than 4 and add them all up for us. Otherwise, we'd have to use this binom PDF command 1, 2, 3, 4, 5 times and do it manually. Okay, so we just put this into the calculator, and this is fine on the AP test. This works. Use this notation though. Don't just put in the calculator notation. Okay, and so that's the answer. No, wait, my bad. I'm sorry. I messed that up. That's not the answer. That's the answer for E. The answer for this one is 0.345. It's getting late. Okay, so last one, but this is important. Pay attention to this one. This time we want the probability, and she gets at least 4. So now we're interested in slightly different set where we want to include 4, but we want to get 4, 5, and 6. We want to add those up. So again, you could do that. You could just do this calculator command 3 times and put in a 5 and then put in a 6 and then add them all up. You could do that, but if n was 60, it wouldn't be practical. So we want to write what's the probability of x greater than or equal to 4. Now, unfortunately, the calculator command only adds from whatever number you give it and then below, or think of it as to the left. So what we have to do is we have to use the complement. We really want 1 minus the probability, and then here we want to say 3. We want to input 3. So it's the probability of x less than or equal to 3. Okay, that's the key. Don't put in 4 here. A lot of mistakes are made. People put 4 in here. So it's 1 minus. Now we can use binom CDF. And what it's going to do is it's just going to add these up, and then we have it subtract. So 6.8 and 3. Okay, and then that's the answer, 0.901. Okay, so that's how you do this problem. For our midterm, focus more on binomial situations. It's good to be able to recognize if something's geometric, but I tend to emphasize the binomial problems. Okay, good luck.